Saturn is a giant planet, one of the most fascinating celestial bodies in our solar system. With its massive size and unique features, it stands out among the other planets. It's the sixth planet from the Sun, located between Jupiter and Uranus. Saturn is a gas giant primarily composed of hydrogen and helium, but what makes Saturn truly special is its rings. These rings are a defining feature, setting Saturn apart from all other planets. These rings are like nothing else in our solar system. They are composed of countless small particles, ranging in size from tiny grains to large boulders. They are huge, bright, and incredibly beautiful. The rings reflect sunlight, making them visible even from Earth with a small telescope. Imagine a giant disk of ice and rock circling a planet. This disk is made up of billions of individual pieces, each orbiting Saturn at its own speed. That's what Saturn's rings are like. They create a stunning visual spectacle, a cosmic dance of particles. For centuries, people have gazed up at Saturn and wondered about its rings. Early astronomers were puzzled by their appearance and nature. What are they made of? How did they form? These questions have intrigued scientists and stargazers alike for generations. These questions have puzzled scientists for a long time. Understanding the rings' composition and origin has been a major focus of planetary science. To unlock the secrets of Saturn, we needed to get a closer look. Observations from Earth were not enough to reveal all the details. That's where the Cassini mission comes in. Launched in 1997, Cassini spent 13 years exploring Saturn and its rings, providing invaluable data and breathtaking images. In 1997, a spacecraft named Cassini embarked on an epic journey. Its mission to explore Saturn and its rings. Cassini was a marvel of engineering. It carried instruments to study Saturn's atmosphere, its moons, and of course its rings. The journey to Saturn was long. It took Cassini 7 years to reach its destination, but the wait was worth it. When Cassini finally arrived at Saturn in 2004, it sent back breathtaking images. These images revealed the true beauty and complexity of Saturn's rings. Cassini would go on to spend 13 years orbiting Saturn, sending back a treasure trove of data. Thanks to the Cassini spacecraft, we now know a lot more about Saturn's rings than ever before. This incredible mission has provided us with detailed images and data that have revolutionized our understanding of these magnificent structures. The rings are made of countless particles of ice and rock, each one reflecting sunlight and creating the stunning visuals we see from Earth. Some of these particles are as small as grains of sand, barely visible even with the most powerful telescopes. Others, however, are as large as mountains, creating a diverse and complex environment within the rings. These particles are constantly colliding and bumping into each other, creating a dynamic and ever-changing environment. The collisions can cause the particles to break apart or clump together, adding to the complexity. Cassini discovered that the rings are divided into different sections, separated by gaps. These gaps are not random but are influenced by various factors. One of the main factors is the gravitational pull of Saturn's moons, which create these gaps and shape the structure of the rings. Cassini also found that the rings are incredibly thin, despite their vast expanse. This thinness is one of the most surprising features of Saturn's rings. If you could stack 10,000 Saturn rings on top of each other, they would be about as thick as a piece of paper. This comparison helps us grasp just how delicate and fine these rings truly are. Section 4. A Cosmic Dance. Rings and Moons. Saturn's rings and moons have a special relationship. The moons help to keep the rings in place. Their gravity acts like a shepherd, herding the ring particles together. But the moons also disrupt the rings. Their gravity can create waves and ripples in the rings. Cassini even witnessed moons stealing material from the rings. This intricate dance between rings and moons is a testament to the power of gravity. It's a reminder that even in the vastness of space, everything is connected. Section 5. The Future of Saturn Exploration. The Cassini mission ended in 2017, but its legacy lives on. This groundbreaking mission provided us with unprecedented insights into Saturn's atmosphere, its rings, and its many moons. The data collected by Cassini has been a treasure trove for scientists, revealing intricate details about the planet's composition and behavior. The data Cassini collected will keep scientists busy for decades to come. Researchers are still uncovering new findings from the vast amount of information sent back by the spacecraft. Each new discovery helps us understand not just Saturn, but also the broader workings of our solar system. And while Cassini may be gone, our fascination with Saturn continues. The planet's iconic rings and mysterious moons captivate both scientists and the public alike. Saturn remains a symbol of the wonders that await us in the cosmos. Scientists are already planning future missions to explore Saturn and its rings in even greater detail. These missions aim to answer some of the most pressing questions left by Cassini, such as the exact composition of the rings and the potential for life on Saturn's moons. There are still many mysteries to be solved. For instance, the origins of Saturn's rings and the dynamic processes that shape them are still not fully understood. Each new mission brings us closer to unraveling these cosmic secrets. One day, perhaps humans will travel to Saturn and see its magnificent rings with their own eyes. The dream of human exploration of the outer planets is becoming more feasible with advancements in space technology and international collaboration. Until then, we can marvel at the images and discoveries from missions like Cassini and dream of the day when we can explore this alien world for ourselves. The legacy of Cassini will continue to inspire future generations of scientists, explorers, and dreamers.